Okay, what I have here is a PowerPoint presentation I'm working on, and I just want to go through it quickly, get you started on it. We have 10 minutes or a little bit less. It says gelatin. Anybody ever hear of gelatin? Gelatin. Gelatin is a type of mixture called a colloid. A colloid is a heterogeneous, we said it before, mixture containing particles that range in size from 1 nanometer to 1,000 nanometers or 1 micrometer. The particles are spread throughout the dispersion medium, and which can be solid, liquid, or gas. The first substances to be identified as colloids were glues. Other colloids include such mixtures as gelatin, paint, aerosol sprays, and smoke. Now remember, smoke can be a suspension. It depends whether or not it's heavy enough to stay in. When I was a kid, teachers smoked in class. When I was in college, they smoked. Here in the United Arab Emirates in 2014, there's much more smoking than at home in the United States. My hallway in my apartment smells like cigarette smoke because somebody at the other end smokes. So it has to be fairly fine, though, the smoke particles, for it to be considered a colloid. Okay. Just a word about nanometers. 1 nanometer, 1/1 is just 1. Divided through by 10 to the 9th is going to be 10 to the negative 9th meters. Just give you an idea, 1 billion nanometers is 1 meter. Yes? Next. Okay, here are some common colloids. And I want to show you this because you are maybe unaware of how to classify certain mixtures, certain things that you see. I don't think you were able to, until today possibly, be able to classify whipped cream. There's a chemical classification for whipped cream. Actually, it's actually more of a physical, but used in chemistry, and it's a colloid. So here is the dispersed phase. In other words, this is the solute. They don't call it a solute. I'm going to call it a solute, but I mean solute. Okay, solute means it's the dispersed. What am I dispersing? Like salt in water is going to be, the solute is a solid dispersed in a liquid. Clear? Okay, so that's going to be the gas liquid, foam, whipped cream, gas solid, a solid sol, marshmallows, pumice, foam, rubber. It's a sol, S-O-L. Liquid, an emulsion, milk, mayonnaise. Liquid in a gas, aerosol, fog, and other aerosols. Okay. Liquid, solid. When's a liquid in a solid? A gel, cheese, butter, shoe polish, jellies. Solid in a gas, aerosol, smoke, dust in the air. When you make an aerosol using smoke particles in air, it's called smoke. Solid in a liquid. Where do I put a solid in a liquid? Like sugar in water would be a solid in a liquid. That's a solution, though. Here, a solid in a liquid would be called sols as well. Paint should be in here. Paint's there. Blood, starch in water, gelatin, muddy water. Okay. Muddy water can also be what?
No, suspension.
I suppose you could make a little bit of an argument for a solution, but it would be a suspension because it's going to settle out. The material that settles out of a suspension called muddy water, what's the material oftentimes referred to as? Think of the Mississippi Delta.
Silt?
Who said that? Yeah, it's very good. Silt. If you take sand, which can be coarse, you grind it up, that's going to be called silt. Here I have a solid. I can have a solid. Okay, that's a solid, called a solid sol. Okay, and that's going to be gemstone and pearls, for instance. Okay, I think we're about. No, we still got time. You can go though. You can go. Okay, you're on the DL, disabled list. Excellent. Okay, next. Table 15.3, what I just did, lists some common colloidal systems and gives examples of familiar colloids. How do the properties of colloids differ from those of suspensions and solutions? Like suspensions, many colloids are milky or milky in appearance when they are concentrated. Like solutions, colloids may look clear or almost clear when they are dilute. The important difference between colloids and solutions and suspensions, the difference is the size of the particles. One more and then we'll quit. Okay? Colloids have particles smaller than in a suspension and larger than in a solution. We know that. These intermediate sized particles cannot be retained by filter paper. They go through filter paper. In terms of chemistry, that's a very, very important distinction. I can't filter out a colloid, but I can filter out a suspension. Okay? As are the larger particles of a suspension, and they do not settle out with time. Colloids can be distinguished by the Tyndall effect and by the observation of Brownian motion. Does anybody know what Brownian motion is? We haven't talked about that yet, really. Yes?
Random bouncing. Random
bouncing. There's an experiment which I'm going to try to set up for tomorrow, but yeah, random bouncing. Okay? They are also subject to coagulation or clumping together, and they can be emulsified or made stable. What's a very classic emulsifier which can stabilize a colloid that we just looked at? It's the four-letter S word called soap. Let's do one more. We have time for one more, and then we'll quit. Okay, here are some, this is a visual on some sorts of colloids. Be careful of this. What's that part, Lee? It could be, it's smoke, a giant fire, chemical fire. You're probably going to have a lot of particles in that, aren't you? Probably, so that's probably part suspension, isn't it? Gel. I have solid sol, which is some gems, some pumice, some marshmallows. Aerosol. I have dust. Downtown Abu Dhabi. Okay, not really. Why isn't that downtown Abu Dhabi? What's the obvious giveaway?
Lines.
What is it?
Power lines.
Yeah, telephone poles. That's like, they have those in Europe and Australia and all those? Yeah.
They're underground here.
Yeah. The newer cities in all countries really are pretty much underground. Fog.
That is downtown Abu Dhabi.
That's Dubai. Yeah, that's Dubai. That's Dubai. The fog. And we have paints. Okay?
Why
and
is cheese over gel?
Cheese. Well, I want you to look that up. I think we already looked at that in the last slide, so you may want to go back and look at that again.
Would cheese be counted as a gel?
Maybe. Why don't you look that up? Yes, Alec.
Is ash a suspension?
Ash is what comes out of, the suspension. When ash settles, like a volcano erupting, ash is going to come down. Ash just means like the burnt particles, the ash. So you have an ash cloud, comes out of a volcano. Okay, if I didn't know there were buildings there, you could say that's a volcano, right? Well, that's an ash cloud. So that's part colloid and part suspension, and we are off.